Hello everyone, and today I'm here with another integral. So the integration of secx dx. So in this video, I'm going to show you two solutions for this same problem. So let us go through the first one. So the first one goes in this way. So you use a trick. So the integration of secx times secx plus tan x divided by secx plus tan x dx. Now why do we use this kind of a trick? It's simple. Well, to get some result, right? So what's the result? So the result goes in this way. So the integration of sec squared x plus sec x times tan x divided by sec x plus tan x dx. Now look at the derivative of sec x. So the derivative of sec x is sec x times tan x. What is the derivative of tan x? It's sec square x, right? That's simple. Well, let us sum up everything and use the formula. So the formula goes in this way. So if the numerator has the derivative expression of the denominator, then the expression can be written as log of f of x, where the integration can be written as in that way, plus c. Now in this case, what is the integration? The integration is log of sec of x plus tan of x plus c. Okay, so this is it. This is the most common integration that you will get in any textbook of integral calculus. I'm going to show you the next solution for this same problem, and it's gonna be quite tricky, but stay with me, okay? So what is sec of x? So sec of x can be written as 1 over cos of x, right? So I'm going to integrate sec of x dx itself. But what I'm going to do is I'm going to simplify sec x so that it'll be more easier for me to handle out. Now, what is 1 over cosine of x? It is sec of x, right? So we can write in this way. And what is sine 90 plus x, or sine pi by 2 plus x? It is basically cos of x, right? So what I can write is, I can write it down as this way, is equal to 1 over sine pi by 2 plus x. Now can you change this type of expression into the double angle form? Now just try this out. It's pretty easy and it's pretty fun. So how can you change this into double angle form? And if you said that it can be changed in this way, you're pretty much correct. So 1 divided by sine 2 pi over 4 plus x by 2. Now I guess that pi over 4 plus x by 2 is being a little more clumsy. Let me substitute that with a variable. So the variable, let me say that it is a. So it can be written as 1 over sine 2a. And that's simple, right? What we have to remember is that a is equal to pi over 4 plus x by 2. Okay, that's simple, right? Now let us go and simplify this particular stuff. So how can you expand this? How can you expand sine 2a? It's simple, right? It's 1 over 2 sine a times cos a. Now there comes a trick. Now it's a turning point of the question. Now please find a trick to simplify this further. And I'll give you a hint. So to get the hint, you have to simplify 1 over 2 sine a times cos a, right? Now to get the hint, look at the numerator term. You have 1, right? And look at the denominator term. You have sine a times cos a. Now how can you use the relation between sine a and cos a to get 1? How can you get the relation between sine a and cos a to get 1 in numerator? It's pretty simple. If you have pretty much good intuition, then you will automatically come with this. Sine square a plus cos square a is equal to 1. So if we have in the numerator, we have sine square a plus cos square a, then we will automatically get 1, right? Okay, so this is done. Pretty good. Now, I have this term left out in this way. So what is in the blank term? So cos a by sine a plus, is there something? Yes, there is something, right? There is sine a by cos a. Now after you simplify that, you will get the same above term. So this expression satisfies. Now, how can you write cos A by sin A? You can write cos A by sin A as cot A. And what is sin A by cos A? It's tan A, right? Great. Done. Now after this, can you write cot A in terms of tan A? Obviously yes, it's 1 by tan A, right? Plus tan A. Now just simplify it, you'll get this expression out here. Okay. Now you have in the numerator, you have 1 plus tan square A. So what is sec square A? Simple, right? It's 1 plus tan square A. Now after you simplify everything out, you brush yourself and you will get with this term. Now look at the A. So can we substitute A with terms of pi by 4 plus x by 2? Obviously yes. After we do this, we'll get with this term. Now after this, we have to integrate this way. Now after we integrate this stuff, it's our final result. As we have already used the formula previously, I'm again going to show you the formula, which is integration of the derivative of the denominator, it's in the numerator, is equal to log of f of x itself plus c. Now let's look at tan pi by 4 plus x by 2. Now we'll try to find, is the derivative of tan pi by 4 plus x by 2 in the numerator? For that we are going to derivative of tan pi by 4 plus x by 2. So what's the derivative of it? It's simply 1 by 2 sec square pi by 4 plus x by 2. Now it's clear that there is the derivative, right? Now we can use the integral. So after we use the integral, we'll get log of tan of pi by 4 plus x by 2 plus c. Now this is the another solution for this type of integral. And yeah, thank you for watching.